Alright, so welcome again in another tutorial of the topic differentiation. So I will not move on in another subtopic. I'm still gonna stay in the product rule. There is something unique about this example, the one you see in your video screen. So I said let me solve first this example and then ndo tutaendelea na kisehemu kinachokuja cha differentiation. So it says find dy dx if y equals to x squared times radical or the square root of 1 minus x squared. So this is a function that is a product of two functions. We have the function x squared and the function 1 minus x squared. So I know I have to use the product rule. So from the product rule we said that dy dx is just equal to u dv dx plus v du dx. This is when y is just equal to uv. So this just, okay, this was y equals to uv ni hivi. Now this is y equals to, so we just let u equals to x squared, and then we are also gonna let v is just equal to 1 minus x squared, square root of 1 minus x squared. So from u here I can easily obtain du dx. It's just 2x. But here now, can I easily obtain dv dx? It's a little bit complicated. The function v, it turns out, is a composite function. So what am I going to do now? I am going to use the chain rule. I'm just going to let, in order to make this simple, I'm going to let w equals to 1 minus x squared. This means that v is just equal to the square root of w. It means instead of 1 minus x squared, I write w. So I can just get dv dx by using the chain rule, where I'll first find dv dw from here, and then I'll multiply with dw dx, which will be obtained from this equation. So this is the chain rule. So let me use the chain rule there to get it, to get dv dx. So I have w equals to 1 minus x squared. So I can easily obtain now dw dx. If I differentiate 1, which is a constant with respect to x, I'll get 0. But if I differentiate x squared, I get negative 2x. I mean, negative x squared is negative 2x. So the final value is just minus 2x. That's my answer, negative 2x. So now v is equal to, so that is dw dx. So v is equal to this, which is just like w times that one. So my dv now, dw is just going to be equal to 1 over 2 w, 1 over 2 minus 1, which is that one. So this is just 1 over 2 w. So now by using the chain rule, my dv now, dx is just going to be equal to dv dw times dw dx. So this 2 and this 2, they can just go away. So I'll just remain with dv dx is just equal to negative x over w. This is just the same as you say negative x over, remember that w is just 1 minus x squared. So I have dv dx now. But also I obtained du dx, which was 2x. But also I obtained u, which was x squared. And also I did not obtain u, actually u I just let. And the v I said was 1 minus x squared. This means now I can use my product rule now. So dy dx is equal to u, this is x squared, times dv dx, which is right here. It's negative x over 1 minus x squared plus v is just radical 1 minus x squared times 2x. So this is my dy dx. So my dy dx is equal to x squared, I said. Then we had this 1 minus x squared. And then we just add with this 1 minus x squared times 2x. So there's a negative here. Napenda tu positive itangulie, okay? So dy dx is just equal to, 2x. This one is the radical of 1 minus x squared minus, we have x cubed over 1 minus x squared. Kwa sababu x times x ni times x squared and x cubed. Now this negative will bring a minus. So this now is the derivative of y with respect to x when y equals to x squared times 1 times the square root of 1 minus x squared. So what I wanted to show is that you can have a particular example ambapo unajikuta inakupasa utumie chain rule humo na product rule humo. Kwa hiyo sio sheria kwamba kuna maswali ya product rule na maswali ya chain rule. Unaweza ukajikuta you use both. So thank you guys. Let's see you in the next tutorial.